Hello everyone. Today we are going to talk about the determinants and area of matrix. Okay, so we are going to work with matrices to represent real world situations and then interpret absolute value of determinants as areas. So we have this scenario going on of the development company wants to divide a large piece of property into smaller lots so that homes can be constructed on them. It is necessary to know the area of each property in the development to determine selling prices and estimate taxes. So triangle OAB is shown below. We want to derive a formula for the area of this triangle in terms of the coordinates shown. All right, so I'm going to warn you, there's a lot of work in this, okay? But a lot of this is just explaining how to, the work explains how to get to what we're going to be looking at, all right? First of all, area of a triangle, I know most of you know, is A equals a half base times the height. But that's when we have a right triangle. Notice that that is not a right triangle, okay? So I'm going to create a right triangle here. Okay, and I'm going to create another right triangle here. I'm going to label this as point C and this is point E. Okay, so I've got a triangle here, a right triangle there, and I have this big right triangle. So essentially what I'm going to be doing is triangle OBE, the big triangle, and I'm going to subtract triangle OAC from that. OCA, sorry. I'll do OCA, okay? And I'm going to subtract this little quadrilateral right there from there as well. So CABE, okay? So this, by doing this, that will give me triangle there, the area of triangle A, or I'm sorry, O, wow, O, AB, okay? So how do we do that? So we've got the area of OBE, we have to find that. So OBE, that will be a half. The base of that is this distance from here to here, which is R. And then the height of that is the distance from here to here, which is S. Okay? And then we're going to need the area of OCA. OCA, so that would be another right triangle. So I have a half, that base is T, and that height is U. Okay. Now I need to find the area of that quadrilateral. So CABE. All right, so area of a quadrilateral, if you forgot, I'm going to write it off to the side of here. A equals a half the base times height 1 plus height 2. Okay, so we've got 1/2. The base of that is this distance, so R minus T. Okay, and then height 1 is S plus height 2 is U, or you could say U plus S, doesn't matter. Okay, and then if I were to FOIL that out, I get 1/2. I'm going to go ahead and FOIL these two binomials here. I get RS plus RU minus TS minus TU. Okay? Now, to find the actual area of triangle OAB, I'm going to do this math over here. So I'm going to do that off to the side. All right, so we've got 1/2 RS minus 1/2 TU minus I'm going to go ahead and distribute this 1/2 all the way through there. So I have 1/2 RS plus, oh, whoops. Yeah, all right, I'm going to put parentheses around that. And around this. So I've got OBE minus OCA minus, and I'm going to write this in. So 1/2 RS plus 1/2 RU minus 1/2 TS minus 1/2 TU. Okay, so I've got 1/2 RS minus 1/2 TU minus 1/2 RS. I'm distributing this negative now. Minus 1/2 RU plus 1/2 TS plus 1/2 TU. And then I'm going to combine my like terms. Let's see, the RS's cancel. The TU's cancel. Looks like we're left with this right here. Negative 1/2 RU plus 1/2 TS, which if I take out the GCF of 1/2, I get TS minus RU. So I wrote the positive first, and then RU was negative, so that's why I put that there. Okay? And you'll see why I wrote it like that here in a second. So that is 1/2 TS minus RU. Okay? Woo, that was a lot of work. So now we're going to write our answer from part A in the form of a determinant of a 2x2 matrix. Well, we got that 1/2 was TS minus RU. That was our answer from part A. So that is 1/2 the determinant of, and we're going to work backwards because remember the determinant, you multiply these terms together, subtracted by these terms multiplied together. So TS times, or minus R times U. Okay? And that kind of makes sense because we've got TU as a point and RS as a point. So that's what that would look like. Okay? All right, and that's why we did the subtraction. That's why I wrote it this way, rather than having those flipped and having negative RU plus TS. Okay? Alrighty, part C. Suppose the points O, A, and B were collinear. Collinear means that they all lie in the same straight line. Okay? We want to show or explain why the value of the determinant would be 0. Well, if I have a straight line, because all the points are collinear, the slope would be 0, right? So, an example to kind of explain that will be if I have U, because slope is rise over run, so U over T, that would have to equal S over R, because they would be, those 2 points would be in the same, on the same line. So the rise will be the same and the run will be the same. So then that would give you, if you were to solve that, you would cross multiply, so you get TS equals RU, which would then tell you that TS minus RU would be 0, because they're in the same line, which means that they have same line. So slope would equal 0. And there's like a little example of why that occurs. Okay? All right, next page. All right, you own 2 triangular pieces of property shown on the map as lot 1 and lot 2. The coordinate values represent distances in feet. So we've got lot 1, lot 2. We want to calculate the square footage of lot 1 and lot 2. So notice that triangle OAB, is that how we said it? OAB, yeah, is right here, okay? That's your lot 2. So let's calculate the square footage of both lot 1 and lot 2. We know that lot 1 is a right triangle, so I can just use the area of that, the area of a triangle. So 1/2, the base of lot 1 is 300, and the height of that triangle is 100. So that is 300 times 100 times 1/2, 15,000 square feet. And we're talking about area, and it says that we are in feet up above in the directions. Okay? All right, now lot 2, from the front side, lot 2 equals triangle OAB. Okay, and we got that area of that triangle is 1/2 TS minus RU. Remember, that came from there. Okay, so we have 1/2. We have T, let's label this. So according to the front, this was point RS, and this was point TU. So we have 300, that's T, S was 400, and I'm going to subtract that by R of 400 multiplied by U of 100. And I'm just going to type that into my calculator real quick. So, multiply that by 1/2, so you get 40,000 square feet. Okay? All right, so we're just using those formulas from the front. All right, part 3, or number 3 says, verify the determinant you wrote in item 1B, which was on the front, is correct by using it to check the values you calculated in item 2. So let's go back to 1B real quick. Right here, this guy, we need to use that, okay, to verify that it equals what we calculated in number 2 for lot 2, okay? So we've got 1/2 times the determinant of T U R S. We're going to do 1/2 times. We got to go find the determinant of that. So you can either do that in your calculator, like do the matrix in your calculator, or just, find the determinant yourself. So 300 times 400, and you're going to subtract that by 400 times 100. Whoops. Which I got 80,000. Okay. Multiply that by 1/2 and you get 40,000, which does check out. They're the same. Okay? So that's just proof that it worked. Alrighty. This was point TU and this was RS, in case you were wondering where those came from. Alright. Number 6. I still am going to need this paper. So in number 6, we said 25,000 square foot portion of lot 2. You want to keep 15,000 feet in the form of a triangular piece with 2 vertices at 0 or at O and at A. The final vertex is located along Division Street. So we're going to cut off lot 2 somewhere in like this little area right here, okay? So we're going to use the determinants to find the coordinates of point D. So somewhere along here, point D will occur, okay? So in order to do that, we're going to have 1/2 the determinant of, we're using point O and A. O is 0, 0, so we don't need to worry about that guy. But we've got A is 300, 100, and we need to find what we want point D to be. Point D will be somewhere along here, okay? So in order to do that, this would be our setup, and we're going to go ahead and multiply that out. So I have 1/2 times 300x minus 100 times x, which gives us 1/2 times 200 of x, which equals 100x. Okay? Now, we want this, we want to keep 15,000 feet in the form of the triangle. So if this, remember, is the area, okay, this represents area, and this 15,000 represents area. So I can set that 15,000 equal to the 100x and solve for x. So when I divide both sides by 100, I get that x equals 150. So that means that point D is at, so x is 150, so I'm going to plug that in. So it's at the x value of 150 and the y value of 150. Okay, that is point D. Now I'm actually going to draw that over here, just to get an idea. So if I got 0, 300, 150 would be like right smack in the middle. So we're going to say that's point D. Okay? All right. Now, point D is what fraction of the distance from O to B. So I'm going to do OD divided by OB. That's what my little fraction is going to look like. So OD divided by OB equals, I know that that distance from here to here of D is 150 over from point O to B, that distance is 400. And then if you type that on your calculator, that is 3/8 of the distance from O to B. Okay? All right, now on number 7, it says not all triangular lots will have a vertex at the origin. So if you guys notice here, none of these points are at the origin. Here we had O at the origin and O at the origin. So if you do not have the triangle at the origin, you can translate the triangle so that it is at the origin. So we have a triangle that can be, the triangle can be translated so that point A, which is the translated point of A, is at the origin. Write the coordinates of A, B, and C. So A, we're moving at 0, 0. B would be R minus T. That's that distance, that X distance. And the Y distance would be S minus U. Okay. And then C would be V minus T. And W minus U. Notice how I matched up the X values and the Y values together. So now we're going to write the area of the triangle ABC using the determinant. So I have 1/2 the determinant of point B was R minus T, S minus U, and point C hold on, let me just check something really quick, making sure I'm not doing anything Yeah, okay. And point C was V minus T and W minus U. Okay. Oh, guys, I'm so sorry. I didn't even move down my camera. All right. So you have point A and point B right there. Or point B and point C. All right. On to the back. Number 8. Describe a method, describe a method for determining the area of a polygonal shaped lot given its vertices in the coordinate plane. So this is just saying that you can divide any polygonal figure into triangles by drawing in the diagonals. So no matter what the shape is, okay, you guys can draw in diagonals to make triangles. That's what it's asking for there, okay? So, any polygonal figure can be divided into triangles by drawing diagonals of the figure. This method we looked at on other problems, and by doing that, you can then apply these to find the area of each little section. So this then can be applied to find each area, and then after that you're just going to add up all the areas to get the area of the polygonal figure. Then add up all the areas for the total area. Okay, one key part though that when you guys do this is you need to make sure that the diagonals need to all come from one vertex. I suggest that point being 0, 0. Okay, so kind of like what we did here, everything was about that point 0, 0, and on this problem we were about 0, 0 as well. And actually same thing down here on number 7. Okay, all right, that's it, guys.